So this lesson has to do with graphs and equations of circles. And first we have a definition of a circle, which is a set of points in the xy plane or the rectangular coordinate plane that are a fixed distance r, that distance is r, from a fixed point, and the coordinates of that point are h and k. The fixed distance r is called the radius, and the fixed point is called the center of the circle. All right, so over here we have the center of the circle, and the coordinates, we could have this x and y, but here they name it h and k, and this is going to be consistent through lots of lessons that we'll see in the future, with a fixed point either being a center or a vertex, and we'll use the coordinates h and k. That distance, that's the same distance all the way around the circle, is the radius. Now, if I'm looking at an equation of a circle, this is an equation that is in standard form. And it is x minus h, which is the x coordinate of the center of the circle, and that's squared, plus y minus k, which is the y coordinate of the center of the circle, equals r squared. Now, if I'm looking at an equation that has the center at the origin, now the origin would be 0, 0. And if I take these points h and k and plug them into this equation above, I'm going to have x minus 0 squared plus y minus 0 squared equals r squared. And if I simplify this, x minus 0 is just x squared, y minus 0 is just y squared, equals r squared. So this is a standard form of an equation if the center is at the origin. The equation of a unit circle would be, a equation or a graph. The center is at the equation, or the center is at the origin, and the radius is going to be 1. So it would be all points that are 1 unit away from the center. Unit actually means 1. So that equation would be x squared plus y squared equals 1. So now they ask us to write the standard form of the equation of a circle with the radius of 5 and its center is at -3, 6. So I'm just going to write this a little bigger. -3, 6 are the h and k values. So if I plug these now into the equation that I have above, I'm going to have x minus -3 squared plus y minus 6 squared equals the radius, which is 5 squared, or x minus 3 squared plus y minus 6 squared equals 25. That's the equation of a circle, center -3, 6, radius is 5. Now they're asking us to graph an equation, or graph a circle that has this equation. So the first thing we need to do is to determine where the center is. Now remember, if I have x minus h and y minus k, I need to find the numbers that are subtracted from x and y here. So if I were to rewrite this as x minus it has a plus here, but I need to be subtracting that value. This would be negative 3. X minus negative 3 is positive 3. So my H value is, for the center, negative 3. Now the y coordinate, y minus 2, I'm subtracting 2 from y, but that's a positive 2. So the k value, which is here, is 2. Now, I always keep in mind if I'm looking at this and I want to real quickly find the center, it's always going to be the opposite of what is inside. So if it's x plus 3, the h value is negative. If it's y minus something, the k value is the opposite of this sign in here. And it works for h and k. You take the opposite sign. So here the h value is negative 3. The y value is the opposite of this, so this is positive 2, or the k value is positive 2. So that's the center of my circle, negative 3, positive 2, that's right here. Now my radius comes from this number, and this would be the radius squared. So if the radius squared is 16, the radius is 4. So from this point, I'm going to draw a circle that has a radius of 4. And I'm just going to kind of plot some guiding points on here, and then we'll draw our circle. But from this point, I want to go up, down, left, and right 4 units. And that's going to give me some points to help me guide where that circle goes. So from the center, 1, 2, 3, 4. Up, 1, 2, 3, 4. Left, 1, 2, 3, 4. And down, 1, 2, 3, 4. So these points are 4 units away from the center. So the rest of this, and I don't draw very good circles, I'm just going to kind of draw this in. They're not connected in straight lines. Remember, this is a curve. All right, so we get those guiding points, and then we draw the circle. On the next page, we're referring to the same equation. So I drew that circle in, and it's asking us to find the intercepts on the graph. Sometimes the circle don't have intercepts. For example, if I have a circle that's out here like this, it doesn't have any intercepts because it doesn't intersect the x or y axis. So what I want to find are the values of the points that intersect the axes. So these are the 4 points. Now, if you remember back in when we were doing lines in the last section, to find an intercept, if I want to find the x-intercept, I set the y value equal to 0. So x-intercept, y equals 0. So in this case, I'm going to put 0 in here for y. So I'm going to have x plus 3 squared plus y minus, or 0 minus 2, because y is 0, squared equals 16. And I'm going to solve for x. So to do this, I'm going to have x plus 3 squared. 0 minus 2 is negative 2 squared, and that equals 16. Then I know that negative 2 squared is 4, so I'm going to move this to the other side. So this is positive 4 when I square negative 2, so I want to subtract 4 on both sides. Now I have x plus 3 squared equals 16 minus 4 is 12. Still solving for x, I want to undo the square. So I'm going to do the square root of both sides. Square root this side, square root this side. So the square root and the square cancel. So I have x plus 3 equals the square root of 12. And that doesn't give me a nice, pretty answer. It's not going to come out to be an integer value because 12 is not a perfect square. So I'm going to simplify this. This is the square root of 3 times the square root of 4, or 2 times the square root of 3. And remember, when I'm solving an equation, this could be a positive or negative value here. So now I'm still solving for x. I still got to subtract 3 on both sides. So the x-intercepts are at -3 plus and minus 2 times the square root of 3. Now this represents 2 points. One point would be -3 plus 2 square root of 3, and this would be -3 minus 2 square root of 3. Now, because I like to have exact answers, these would be the exact answers. Okay. Now, if I were to find these on my graph, these are x-intercepts. So this point right here would be negative, whoops. And sometimes it helps us to get an estimated value of what this might be. So if I, on a calculator, did -3 plus 2 times the square root of 3, I'm going to get about 0.46. All right, so that's where this is. So this would be x equals -3 plus 2 square root of 3. Now, on the other side of this, on the x-axis, I'm going to have -3 minus 2 times the square root of 3, and that would give me approximately -6.46. So that kind of makes sense right here, that this value is approximately -6.46. Or exactly, this would be -3 minus 2 times the square root of 3. So those are the x-intercepts. Now we're going to do the same thing and find the y-intercepts. So let me do this. So the y-intercepts means x equals 0. So in my equation up here, I'm going to have 0 plus 3 squared plus y minus 2 squared equals 16. So 0 plus 3 squared, 0 plus 3 is 3, and 3 squared is 9. So this is 9 plus y minus 2 squared equals 16. I can subtract 9 on both sides, and this will go away. And I have y minus 2 squared equals 16 minus 9, which is 7. To undo the square, I need to do the square root. So this becomes y minus 2 equals plus and minus the square root of 7. And solving for y, y equals 2 plus and minus the square root of 7. All right, so that's going to represent these values here. Now, 2 plus the square root of 7, I'm starting here, I'm going up the square root of 7. That's what this value is. And 2 minus the square root of 7 is right here. If I just calculate what these values are, one value will be approximately, square root of 7 is about 2.6. So 2 plus 2.6 is about 4.6. That's what we would have up here. And down here, 2 minus 2.6 would be about negative 0.6, which is about what we have right here. All right, but when we're finding the intercepts, we want the exact value. We use the estimated values to just kind of check to see if they're in the right spots, or does it make sense. In this last example, it's asking us to graph this equation. Well, this equation looks nothing like the standard form that we saw at the beginning. Remember, the x plus or minus a number squared and y plus or minus something squared equals r squared. This is expanded out. So if I were to multiply something like this out, I would have an x squared, an x term, a plain number, and that's kind of what I see here. An x squared, an x term, and a plain number. And then I have a y squared that's been FOILed out. So really what I want to do is undo the foiling that's here. So to do that, I'm going to use the method called complete the square. All right. So to complete the square, what I'm going to do is reorganize some of these terms. So I'm going to have some terms that are x terms, and I'm going to have some terms that are y terms, and then that's going to equal some number. All right, so I'm going to take the x squared and the 4x and put them in this set of parentheses, x squared plus 4x, and I'm going to make this a trinomial. So I'm going to put a number here in a minute. Then I'm going to take the y squared terms, so y squared minus 6y. I'm just grouping the y's together. And then I have another number that I'm going to put here. And then I'm going to send the 12 over to the other side. So this is going to be negative 12. What I want to do is make this a perfect square trinomial so that I can factor it and make it the square of a binomial. So I need a number here that's a perfect square. To find that, I'm going to take half of this middle term. So half of 4 and square it. Half of 4 is 2. 2 squared is 4. So I'm going to add 4 here. But remember, an equation's like a balance, so if I add 4 to this side, I got to add 4 to this side. Same thing for the y's. I'm going to take half of the middle term, so the sign is negative, so I'm going to keep that negative. So I have negative 6, half it, that would give me 3, and then I'm going to square it, and that number goes at the end. So 3 squared is 9, and remember, when I square something, I always end up with a positive. So now I'm going to factor this. So this becomes x, numbers that multiply to before, add to before are plus 2, and x plus 2, so that's a square. Then I'm going to have over here numbers that multiply to be 9 and add to be negative 6 are negative 3 times negative 3. So this would be whoops, I wrote this wrong. Half of 6 is 3. Well, and I didn't even write that. Sorry. This was right. But this number ended up being 3, half of 6. This is the number that's going to go inside here. So the numbers that multiply to be 9 are 3 and 3. So this would be y minus 3 squared. And that equals what's over here. And again, if I added 9 to this side, I got to add 9 to this side. So I got to add 9 here. And now I started off with negative 12. I added a 4 here, so I added it on this side. I added a 9 here, so I added a 9 to the other side as well. If I add these up, negative 12 plus 4 plus 9 is positive 1. When it's in this standard form, now I can find the center of the circle, which would be, remember our h and k values? The opposite of this sign would be negative 2. That's our h value. Our k value is the opposite of what's in the parentheses with y, so that would be 3. So this is the center of our circle, negative 2, positive 3, right here. And this number is r squared. So if r squared is 1, the square root of 1 is 1, so the radius is 1. So now I'm going to go 1 unit up, whoops, that's right here, 1 unit down, 1 unit left, and 1 unit right. So here is my circle. That's nothing. All right, so that was just a quick completing the square, and we'll probably do another example or two in class just to get into some practice with that.